This lesson covers section 6.3 in your textbook, and it's about solving multi-step inequalities. First, we need to review some operations that are and are not okay to do with inequalities. Notice the inequality shown here. 4 is less than or equal to 6. This is a true statement because 4 is less than 6. Notice that it's okay and our inequality remains true if we add the same thing to both sides. For example, if I add 2 to both sides of the inequality, I get a new statement. 6 is less than or equal to 8. And this statement is true as well. It's also okay to subtract the same thing from both sides of an inequality. For example, if I start with an inequality that's true, 4 is less than or equal to 6, and I subtract 2 from both sides, I get a new statement, 2 is less than or equal to 4, and this is also true. To visualize this on a number line, let's plot the numbers 4 and 6. You can see that the blue dot representing 4 is less than the purple dot representing 6 on the number line. If we add the same thing to both sides of an inequality, it's as though we simply take these two dots and shift them both up by 1, but their position relative to each other stays the same. Here's a question for you. Is it okay to multiply both sides of an inequality by the same thing? When is it okay to do that? Is it always okay? Is it sometimes okay? Is it never okay? Here's what I'd like you to do to challenge your thinking on this question. First, write two different numbers and leave a space in between them. It'll be helpful if your numbers are relatively small integers. So for example, you would not want to pick a number like 3.86152. This will make the math that comes later a little bit more difficult. And you wouldn't want to pick a number like 2,386,421 because that'll also make the math difficult. I'm going to use the numbers -3 and +6. Your two numbers may be different, and that's fine. Next, choose the appropriate inequality sign to place in between the two numbers. In my example here, I'm going to show that -3 is less than 6. That is true. Now I want to pick a third number and multiply both sides of the inequality by that third number. In my example, I'm going to multiply both sides of the inequality by 2. When I do that, on the left-hand side of the inequality I have -6, and on the right-hand side I have 12. It is true that -6 is less than 12. The question is this: can you find a number for step 3 above? A number that when you multiply both sides of the inequality by that number, the answer you get is wrong. Pause this presentation for a moment while you try and find a number that makes both sides of the inequality no longer go with the symbol in between them. If you can find a number, go ahead and resume this presentation. If you've tried for a while and you can't find one, you're welcome to move on. So let's take a look on a number line at what happens when we multiply both sides of an inequality by a number. What's shown on the number line above is I start with an inequality. 1 is less than or equal to 4. Those are the two initial dots there. You'll see a blue dot over the number 1 and a purple dot over the number 4. And 1 is indeed less than 4. If I multiply both sides of this equation by 3, what happens is that the blue dot still stays to the left on the number line of the purple dot. 3 is less than 12, but they get separated by an even bigger amount. The one that was bigger is now even more bigger. And it shows that it is okay to multiply both sides of an inequality by the same positive number. But watch what happens if we do a negative number multiply on both sides. We're going to start with the same inequality. 1 is less than 4, and that's shown with the two dots on the number line above. If I multiply both sides of this inequality by -3, 4 times -3 becomes -12, and 1 times -3 becomes -3. Notice that the order of the dots reversed. It's like the dots flipped over each other. When we multiply by a negative number, we need to switch the order of our inequality sign. We need to turn our inequality sign around. Because if we didn't, what we would get when we multiplied both sides by -3 is this inequality. -3 is less than -12, and that's not true. Multiplying both sides of the inequality by a negative number resulted in a false expression. Please make sure that you have this important concept highlighted in your notes. When you multiply or divide both sides of an inequality by a negative number, you must reverse, you must flip around the inequality sign. Let's do some practice on this. I want to figure out what values of x would make this inequality true. 3x is greater than 15. I can use the same steps that we've used in the past to get x all by itself. If I divide both sides by 3, in this example to remove the coefficient from the x, what I get is x is greater than 5. And I didn't multiply or divide by a negative number, so I don't need to switch the inequality sign around. So if I plug in any number for x that's greater than 5 into the original inequality above, I'll get a true statement. To check this, I can plug in any number that's bigger than 5. Let me try 6 in the original inequality above. If I plug 6 in above, is 3 times 6 greater than 15? It is. 3 times 6 is 18, and that is greater than 15, so that works. Let's keep practicing here. Here's another inequality. -3x is greater than 15, and I want to know what numbers I'm allowed to plug in for x to make this inequality be true. Step 1, I still want to remove the coefficient from x. I want to get that -3 away. And so to do that, I'm going to divide both sides of the inequality by a -3. I need to stop and check to see if I need to reverse the inequality sign. Here, I divided by a negative number, and so I do need to turn that inequality sign around. When I simplify, I'll have x on the left and -5 on the right, and notice that I go from a greater than symbol to a less than symbol. I switched my inequality around. When I plug a number in to check, let me pick a number that's smaller than -5. Let me try -6. If I plug -6 into the original inequality above, what I get is -3 times -6 is greater than 15. Is that true? Well, a negative times a negative is a positive, and 3 times 6 is 18. And 18 is indeed greater than 15. Notice that I needed to turn the inequality sign around to make sure that my final solution, x is less than -5, was correct. We need to look at how to graph the solutions to this inequality. Here's a simple inequality. X is greater than 8. What are some numbers that x could be? Well, you can think of a whole bunch of numbers that x could be. X could be 9 or 10 or a million or 8.0001. X could be anything bigger than 8, but not 8 itself. To show this on a graph, what we want to do is to highlight or to color over all of the numbers that are solutions to this. So all of the numbers that are bigger than 8 are now covered over by this red arrow. The red arrow continues to the right forever and ever, indicating that anything bigger than 8 is indeed a solution. Now we can get really, really close to 8, but 8 itself is not a solution. The way we show that is we draw an open circle around the number 8. That indicates you can get as close as you want to 8, but the point 8 itself isn't highlighted in red. It is not a solution. To show x is less than 8, we would highlight over everything less than 8 on the number line. And again, we would draw an open circle around the number 8 itself to show that 8 is not a solution, but numbers very, very close to it are. If we have x is greater than or equal to 8, in this case, x can be all kinds of big numbers and x is allowed to be 8 as well. So we would show everything bigger than 8 highlighted over in red here, and we would draw a closed circle, so the number 8 itself is colored over. Any point that's colored over by this red arrow is a solution to the inequality below. So for example, I can see that the point 9.5 on this number line is highlighted, and 9.5 is a solution to this inequality. If we want to show x is less than or equal to 8, we show everything less than 8, and then a solid circle over the number 8 itself. So if I show you a graph and ask you what inequality goes with this graph, well, it looks like what's shaded over in red are numbers that are smaller than 5 and 5 itself. The inequality that goes with this is x is less than or equal to 5. This is the end of section 6.3.